I like that. That's very nice.
I think
And you guys have to play the whole time.
They stick a needle in you.
Yeah,
It doesn't matter because I'll get like one.
Okay. Alright guys, so here's the homework. Do you guys have any questions? First period several of my students were uncertain about how I kept finding the vertex. Well, if we factor this, it factors to x plus 5 and x plus 1. So my x-intercepts are -5 and -1. So to find the vertex, if I just average those two, that gives me that the axis of symmetry is x equals -3, and that's the x value at the vertex. So if I plug in -3, then I get out -4 as my y, and that's how you find the vertex. Every time. You can just average these two. If you can't, just look at it and tell. Okay? Any questions about 1, 2, 3, or 4? Yes, ma'am.
Okay, so how did you get the coefficients outside the parentheses? Like, I have those numbers inside.
Okay, when we factor, our first rule is to look for a GCF. And if we have one, it should always be factored out first. So in this problem, since there's a common factor of 2, we can factor that out first, and that leaves us x squared minus 4x plus 3. And so we get 2 times x minus 3 times x minus 1.
Yeah, that's wrong.
Now, you still got the right zeros, didn't you?
I did.
Yeah, but you wouldn't have the 2 factored out, but it would divide it itself back out. Okay, any other questions? All right, let's take a look at the next one. So this is a word problem. All right. Because we want to look for the zeros, we're going to factor out the -0.02 and the x. And do you see how now we have this written as the product of the factors? This is one factor, this is the other factor. So we have a 0 at 0, and then another one at 45. So we know that's where this crosses. And to get the maximum, you can just add those two up and divide. We get that the axis of symmetry would be x equals 22.5, and we can plug that in to get the maximum value of the function. Definitely using a calculator on this one, because I'm squaring the 2.25 and multiplying it by -0.02. And then we get that as our y value. Did it ever download?
Yes.
Good.
I know we're talking about homework.
All right. And let's take a look at number 6. Now, we talked about this. I wrote it on the board briefly. This book describes factored form a times x minus p times x minus q. And if we look at this, we probably would have written it like this because p and q are the same. And then they talk you through, then obviously that x-intercept is also the vertex. And we talked about that yesterday in class. Yes, ma'am.
Okay, so what's it asking for C? didn't understand what I was asking. Just the formula?
Yeah, I'm
Yeah, I was
okay.
confused.
I'm okay if you don't get that one.
Okay.
I'm okay. Because we didn't stress in the Q thing yesterday. But you should notice that this, if we do write it as a binomial square, this is vertex form. So it's been shifted left 3, and your moves are multiplied by 2. Vertical stretch by a factor of 2. Yes, Yuri Grace.
For number 5 on the bottom,
Yes.
a -4 and a +5.
Okay. I put up my workbook. Can I borrow yours for a second?
Yes, you may.
So number 5, the problem originally was g of x equals x squared plus x minus 20. So it factors to x plus 5, x minus 4. That way we can get the positive 1 there. So what would make this factor equivalent to 0?
-5.
-5, so that's my 0. And this factor is positive. All right. Okay, so let's talk about the different ways we've worked with quadratics so far. First thing we did was vertex form. Do you guys remember vertex form? And then we looked at standard form. But what was our little nice shortcut on standard form that helps us find
-b over 2a.
negative b over 2a? Then we looked at intercept form, which is basically factored form, isn't it? And today, we're going to take ones that are in standard form and write them back into vertex form. So instead of using our little shortcut of negative b over 2a, we're going to take standard form and rewrite it into vertex form. Now, I know I have a lot of people that are good thinkers in here. And as we're doing this today, you're going to go, why would I do it this way if I could just do negative b over 2a? Because that gives me the x value, and I can write it in vertex form. I've already done it the other way. Today we're going to learn how to put it in vertex form by completing the square, because there are other types of functions that we need to be able to complete the square on. All of our conics, we will need to be able to complete the square to put them in forms that we can graph them. And the quadratic is a parabola, isn't it? It is one of our conics. And it's the first conic we're actually looking at. And we're not even calling it a conic right now. We're just looking at it as if it's just the quadratic function. So we're going to later on do circles and ellipse and hyperbolas. And we will need to be able to complete the square on all of those. And I looked up some real world applications. Some of it was like shoo, right over my head. But we can discuss some of it. But mainly it would be used in the design of anything that needs to be elliptical in shape. Or we'll talk about that when we get to the conics. Parabolic or hyperbola is more like a seminar reflective thing. But there's lots of application for it. We're just not ready for it, the application part, just yet. Yes, sir.
It's a little off topic, but when someone asks the square root of something, do we put like positive, negative,
Okay,
whatever?
that's a good question. Here, let me address that. There are two different ways. If we are solving an equation such as this, n squared equals 36, there are two answers, because if I use positive or negative 6, it makes a true statement here. But if I gave you this, what is the square root of 36?
6.
This is just positive 6. Because if I gave it to you in radical form, we're just doing the positive unless there's a negative out in front.
Oh, okay.
So if you have to add in the radical to solve it, then it's plus or minus. But if you're already given the problem in radical form, then it's whatever sign you were given.
Ah, okay. Thank you.
You're welcome. All right, so today we're going to complete the square to graph, and then after that we're going to complete the square to solve our quadratics. I'm going to go ahead and let you write all this down so that we can work through it and you won't be overwhelmed by the speed of the writing. any of you have a view of the dance hall?
Yes.
Yes.
I tried.
Were there any teachers? No. Aw. Mr. Little is probably the best dancer in the whole school. And sometimes he dances during this week. Yeah.
Wait, is he not here anymore?
Oh, he's here. He's the art teacher. Today he has on his 70s gear, and his hair is out like this.
What are the different forms we went? I'm just gonna write them down.
We've done vertex form, standard form, intercept form, and now we're coming full circle because we're taking something that's in standard form and rewriting it back into vertex form by completing the square. Okay, so now most of us would look at this problem and go, I would not do vertex form because this, what happened? Stop. I'm not sure what's this, okay, because this factors really nicely, doesn't it? It factors simply into x minus 6 and x minus 2, and then it would be really easy for me to graph it. Thank you.
How to go columns.
Okay.
Good.
Thank you.
Don't pay. I know, that's the whole point.
All right, so what we're going to do, even though we can do it this way, and if you're given free choice, that's the way I would do it. But what we're going to do is we're going to take this simple equation here, and we're going to rewrite it in vertex form by completing the square. To complete the square, we're trying to create a perfect square trinomial. Because anytime we have a perfect square trinomial, we can write it as a binomial squared. That's why they call it completing the square, because we're going to write it as a binomial squared. Well, to complete the square, we would need a perfect square trinomial. This would need to be a perfect square. I'm going to show you two different methods of doing it, and you can go with either. But with the first method, what I want you to do is, if this is not a perfect square trinomial to start with, I'd like you to take the constant and move it to the other side of the equation. We're using the subtraction property of equality right now because I'm subtracting 12 from both sides of this equation, and it remains balanced. Okay, when we were factoring, we did some of these problems for homework. What would I have to add right here to turn this into a perfect square trinomial? This is a perfect square. What would I have to add right here to make it a perfect square trinomial? Can anybody tell me? 16, good. Now, if you can't just look at it and tell, to get this number, we always take half the coefficient of our linear term, half of the coefficient of the linear term, and we square it. So what is half of negative 8? Negative 4. But negative 4 squared is positive 16. Now, to keep an equation balanced, whatever I add to one side of it, I must also add to the other. The addition property of equality just occurred. So now the left side will simplify to f of x plus 4. And the right side of the equals can be written as a binomial squared. Once we create our perfect square trinomial, every time we're going to rewrite it as a binomial squared. How would this factor into a binomial squared?
X minus 4 squared.
X minus 4 squared. And then we move our constant back. So we get f of x is equal to x minus 4 squared minus 4.
What's that form called?
This is vertex form. So that's what we're doing. We're completing the square to write it in vertex form. So we started out with this form, which is standard form. Now yesterday, we looked at this form, which is intercept form. But today what we're doing is we're taking standard form and completing the square to write it in vertex form. So when it's in vertex form, it's really easy to see the vertex. The vertex is always the opposite of this, and what's added to the end stays the same. So the vertex as is located at 4, negative 4. And if we were to graph this, we would come over to 4, down to negative 4. A is the understood 1. So 1 squared is 1, 2 squared is 4. And it's symmetric across the axis of symmetry. So I would just copy those points on the other side. And there's my graph. Now, do you see I have an intercept at 6 and at 2? If I had used intercept form, does this show I have an intercept at 6 and 2? Yeah. But this just gives us another way of graphing a quadratic. Now I'm going to do one more with you before I ask you to try one on your own. Nope, I'm going to do 2 more with you. Alright, let's look at number 2. So number 2 is y equals x squared plus 10x minus 13. So the first thing I want to look at is this already a perfect square trinomial? No, it's not. So I'm going to move the 13 over. And then create my perfect square trinomial. What do I have to add to these two terms to create a perfect? 25. Now to keep the equation balanced, whatever I add to one side of an equation, I must also add to the other. So the left side of this equation simplifies to y plus 38. And the right side can be written as a binomial squared. What is this as a binomial squared? X plus 5. So this can become x plus 5 squared minus 38. Now, I just want you to watch this one, and you can decide if you like it better. You're welcome to use this. All right, on this one, I'm not going to move the constant to the other side. Just going to kind of separate it off a little bit. And I'm going to go, all right, to complete the square, I'd need to add 25 to this. But to keep the equation balanced, I'm going to subtract 25. What is adding and subtracting? They cancel each other out. It's like using the additive identity when we're basically adding 0 to this side of the function. If I add 25 and subtract it on the same side, does that make sense? And then you could write this as y equals x plus 5 squared minus 38. Do you see how you get the same thing? You can choose either way, whichever one you like better. It doesn't matter to me. Okay? All right, let's take a look at number 3, and then I do have one for you to try. So go ahead and write down number 3, and we'll solve it together. Because number 3 has a coefficient, a leading coefficient, other than 1. On this one, we're going to move the constant over so that we can rewrite this as a perfect square trinomial. But when we have a coefficient, that coefficient will have to be factored out before I can complete the square. Do you see this has a coefficient of 2? So we have to factor that out. And when we do, we're left with x squared minus 4x. Now, we're not factoring out the GCF. We're only factoring out the coefficient because we still want to make a perfect square trinomial. And if we factored out the GCF, then we wouldn't have a perfect square trinomial. So we're just factoring out the coefficient. Well, now can you tell what I need to add here? Take half and square it. So what am I adding? 4 here. But what if I take half the middle term?
Oh, you took the GCF out.
I took the, yes. If it has a coefficient, you have to factor it out. Okay?
Wait, but then how do you get 4?
I factored the 2 out of both of those.
No, I mean, but on the end.
Well, now I'm completing the square. So what do I have to add here to turn this into a perfect square trinomial?
Well, wouldn't it
You take half.
Then that would
half
be
and
8.
I was thinking
That
why
would be
was it
then
the
that would
same
be,
number,
it would
but
have to
half
be
is
plus
2.
16x.
Okay. So
Okay.
right here it's 4 to turn this into a perfect square trinomial. But what value did I add to the right side of the equation? I added 2 times 4, didn't I? So to keep the equation balanced, what must I add to the left side? 8.
Oh, because the 2 is going to...
Because the 2 gets multiplied times that.
So how is that a perfect square trinomial?
Well, how does this, if I just gave you this, Brian, how would you factor it?
X plus 2 squared.
Minus 2.
Oh, minus.
So I created a perfect square trinomial. So this factors to x minus 2 squared. And then we have the 2 out in front. And over here now we have g of x plus 5. And then we move the 5 back over. So we get g of x equals 2 times x minus 2 squared minus 5. Okay. I want you to try number 4, and I'm going to walk around, and if you get stuck, I want you to ask me for help. Next year you take
minus 128.
Twice as fast, right?
But then you have to subtract 125.
It was 103.
How did you get 1? No, but use the, no, it would use the
28 over there. And then once you get like,
but you have to do it times that. Plus 1. So that.
Finding what goes here, so I'm sure you take half and half.
What's it?
-5, that's where 5 times 5.
Money.
I tell. So much fun.
homecoming better be sick.
Are you going hard?
Any negative so if I pay
I wish we could still wear this in public.
it's still Hollywood.
You find that shit?
It's still silly blood for
I wish I was like.
50s.
No.
Those are bomb babies.
That's awesome.
But eggs are good eggs.
I live in 40 years.
Yeah, maybe you need to
We never learned about 40.
Let's 56 maybe you can go to
Good JV.
I just factored out 5. Like Michael. Yeah, just.
I didn't know what intercept form looks like. I didn't know
Chris Coach. You the best dog.
Oh, sorry.
Yeah, you were.
Back in the good old days. Is that like your sister, you go to like the ice cream park? I think that's so cute. Everything's like 5 cents. Well, it's not like it was any less expensive. I know there was less money. So 5 cents is worth a lot more. It's not like oh, 5
Maybe I wouldn't
cents.
have
Yeah,
but I would have.
it's the exact same amount of money.
Yeah, but it'd be cool like if we could take our money and go back in time.
Was he too?
you have a job.
Okay. All right, guys, let's go look at this one. So, the first thing we're going to do is move the 128 over. And then we're going to factor out the 5. So I'm going to do 2 steps at once here. Okay. When we do that, I've set this up to create a perfect square trinomial. So if I take half the 10, which is -5, and square it, I get positive 25. But because there's a 5 out in front, I've added a value of 125 to the right side. So I have to add that same value to the left side. So this gives me f of x minus 3 equals 5 times. Well, the whole reason I did this was so I could create a binomial squared. And so this factors to x minus 5. So now I have completed the square. And I can move the 3 back over to put it in vertex form. So now I know my vertex is the point 5, 3. And I can graph it, and I know my moves are multiplied by 5. Okay? All right. Last period wanted 1 one more you try. Do you need one more?
I don't think so.
Okay. Okay.
You try.
Let's take. I'm gonna give you just 2 minutes. Some of you want it, some of you don't. If you want it, let's try. If you don't, you can sit quietly.
Yeah, I'm gonna do it.
I'll do that.
I didn't do it.
Is this like the same thing we've always been doing? Since day one?
But
So if it's positive here, it's positive here. If it's negative here, it's negative.
ow. Okay, first step. -7. Oh, you take out the GCF. No, the coefficient only, obviously. F of x minus 7 is equal to...
You should actually kind of like do it.
Whoa.
Same number.
You only get like half.
I like this way a lot better. But once again, it's probably going to get the same thing hard about 5 times. So.
Yeah. Oh, by the way.
Oh, by the way, I forgot to tell you this.
It's hard. Well, I got it right.
Okay, so you got this. I got it. 3 x
You want me to leave it on the next side? I'd be happy to.
How did that... I never... Oh!
Yeah.
How did that occur?
Four.
You just have to, whatever this is, you do the opposite here to keep it at 0.
Why do you have 3? Because
So when you add the 1 to make it a perfect square triangle.
see, it's really 3 times 1.
Yeah, you gotta add.
Why do you add a 1?
To make it a perfect square triangle.
Yeah.
Okay. How do we do on the subtract?
Do you know what in mind?
Are you kidding me?
Maybe the homework will fix that. Okay. If you need to come to Aagaa, that's fine. Alright, now we're going to use the same method to solve equations. This is easier. We did the harder part first. You're going to be happy.
Corners.
Okay. So we're going to use the method of completing the square to solve quadratic equations. So you see these are not functions, these are just equations, so we're finding the solutions or the roots of the equation. Well, look at number 6, x squared plus 10x plus 25. This is already a perfect square trinomial, isn't it? So do I need to add anything? No, I just need to write it like this, x plus 5 squared. And then what did we do on our warm-up?
Take the square root.
We took the square root of both sides, didn't we? And so we get x plus 5 equals positive or negative, and this breaks down into a product of 9 and 3. So when I take the square root of that, I get 3 root 3. And then move the 5 over.
Do you not have to write like 5, like the whole back?
Sure. I mean, I'm okay with you writing plus or minus as long as you understand that it means these two answers. As long as you have an understanding of that, I'm okay with you just writing plus or minus here. Alright, now, is this one a perfect square trinomial? No. So I gotta do a little more work. What do I need to do?
Make it a perfect square.
Yes. how do I make this one?
Make it.
Add 36.
To both sides.
Yes, I do. Add 36 to both sides.
So, oh my, sorry, that's 4x minus 6.
So this gives me x minus 6 squared is equal to 56. And then I take the square root, plus or minus. And this breaks down into 4 times 14. So I get x minus 6 is equal to plus or minus 2 root 14. And the square root of 14 doesn't simplify anymore, even though we might want to make it. So we get 6 plus or minus 2 root 14. Okay, I want to do one where there's a leading coefficient and the bell's about to catch me. So we're going to skip this one. You just have to put it in the right form. So we'll go to number 9. Do you see that this does not have a leading coefficient of 1? Oh, this is so much nicer. Watch this, guys. It has a leading coefficient of 2. Go away. Go away.
Yeah.
Okay?
See ya.
Yeah. So we get x squared plus 4x equals 6. And I can do that because there's not an f of x over here. When I had f of x, I can't divide by the 2 because it'd just be f of x divided by 2. That doesn't help me. But I can here. So here I would add 4 and 4. I would write this as x plus 2 squared equals 10. So x equals negative 2 plus or minus the square root of 10.
So what